So today we'll discuss about the data types. Right, the introduction to data types I have discussed in the last class. Today probably we'll continue with the same and see their details. Okay, with respect to different languages. Okay, so when we are studying programming languages here, it is not pertaining to a particular language rather, right? We generally discuss all these concepts in a very general manner rather. But then in order to understand these programming constructs, we need to take some programming language syntax and its implementations. Only then we can probably understand. So that is the reason why I had last class discussed about the data types with respect to C language. Since you have already studied C language in first year, you have idea about data types. So that is the reason why we have discussed with respect to data C language. So that now you may have got the idea and the importance, necessity of the same. Right now we can probably move into the detail of the same, and by comparing these data types which are being offered by different programming language, we can rather discuss and their characteristic. Of course, we have discussed in the last class, but then we could again discuss in a more detailed manner, rather, right? So the classification of the data types, probably in the last class I have discussed. I have done it in three what we call classes. One is built-in, I said, built-in data types. And then I said user-defined data types. Then I said derived data types, right? Derived. So under built-in, I may have said int, char, float, long, int, and all. Under user-defined, I've said the structure, unions, functions, enumerated, and of course bool or boolean data type, which is not as part of C language available, but in C91 onwards it is available. But it is also considered to be a data type in C++ or Java, and Boolean or bool kind of thing, which is being derived from enumerated only, rather, right? And structure and union similar to each other. They are used to maintain the records. We say this is to maintain the records, and this is used to maintain the invariant records, right? So under derived data types, I have said arrays, and pointers. So instead of that, you may have now here seen the classification in this book. This is Sebasta. About Sebasta. So where the classification of the same is given in a different manner, but they are being all covered as part of what the classification have given before, rather, right? Primitive data types like int, char, float, and also. So here then character string data types, right? The set of characters is set to be the string. Then here ordinal data types, so basically the enumerated and all kind of thing. Then arrays data type, which we have discussed before. Of course, right? Associative array. When you have more than one, attribute for each element in the array, we say associative arrays, rather, right? Then record types, so basically structures and unions. Structures are said to be the record types, right? In Pascal, we say records. Then union. Union also we have discussed. It is said to be invariant records in Pascal. And then pointers and the references. You may have seen a new thing called reference, which you may have not seen in C, but from C++ onwards you will find this reference kind of variable. Of course, right? Pointer, of course, you have already studied in C. Fine. So we'll discuss about all these things probably again in detail in the particular class. Okay. A data type defines a collection of data objects and a set of predefined operations on those objects. Right. This is the definition we also had given in the last class, right? Collection of data objects or elements, I said, or some data. Right? But then over here, predefined operations, right? As I said, this, if you don't mention, the definition of this data type will not be complete, right? It's a set of operations performed on those objects. Okay, and a descriptor is the collection of the attributes of a variable. Okay, so what kind of attributes that a particular variable consists of is nothing but the range of values, right? For example, integer, when you say, so you have limit. If it is a short int, right? What attributes that it can carry with, rather, right? Minus 2 power 15 to plus 2 power 15 minus 1 means minus 32,000 in decimal. If I decimaling from right, minus 32,768 to plus 32,767. So this is a set of attributes, rather, right? An object represents an instance of a user-defined data type. For example, you have structure. Okay, you are defining a structure like student and all kind of thing. Okay, you have set of attributes or members to this student. But in order to implement this particular student, okay, structure for one student, how do you do that? You will create one instance or the variable of this kind, which is said to be the object, rather, right? Is said to be the object. One design issue for all the data type: what operations are performed, are defined, and how they are specified is what an issue, rather, right? So, as I said, when you are defining a data type, then predefined operations which can be performed on that respective objects, collection of objects, right, which are grouped together under that particular data type, have to be mentioned. Of course, this is one of the design issue of the data type. So the language designer, when they are defining data type, they need to mention the set of operations which can be rather performed on that particular data types. Okay. Yeah, primitive data types. In primitive data, almost all the programming languages provide a set of primitive data types. Right? Primitive data types are those that are not defined in terms of other data types. It means they cannot be defined, further. I mean, they cannot be further divided. Or the other way around, you can say the atomic data types, right? They're said to be the atomic data types. Like, for example, if I have int kind of thing, okay, so it is used to represent the integer numbers, rather, right? Like, if I have a structure, the structure I can define it with respect with the collection of some other set of data types or primitive data types. So these kind of things are said to be non-primitive, rather, right? So primitive are those which cannot be defined in terms of other data types, right? Like basically integer, character, these are said to be what the primitive data types in many of the languages, right? Integer, almost always an exact reflection of the hardware. So the mapping is, so there may be as many as different integer types you have, right? If you probably take Java language, in Java language, integer is a family here, right? In Java language, integer is a family. So integer consists of, again, set of data types. Byte means byte or short or int or long. So in Java, of course, in C language, int is one single data type, rather, right? It could be short int or it could be long int, right? But in Java, you can see integer consists of 4, of its family members. One is byte. Byte is a single, one which consists of how many bits? 8 bits. So byte consists of how many bytes? It's going to be 1 byte, right? It's going to be 1 byte. 1 byte means 8 bits. Short. Short consists of here 2 bytes. Int consists of here 4 bytes. Long consists of here 8 bytes. This is a difference in Java, right? Whereas in C, what we have said, in C language, there are two type of ints. You have short int, you have long int, right? Short int consists of how many bytes? 2 bytes, and long int we said 4 bytes. But when you come to Java language, in Java language you may have seen the difference, right? Integer consists of 4 family members. One is byte, okay, to represent the bytes, okay, consists of 1 byte. And basically here in Java, what happens? The entire program. After you compile the program, you write the program and save it with .java extension, right? For example, you have addition of 2 numbers, like add.java. Then you compile it first, right? When you compile, what happens? It generates a .class file, right? This .class file consists of universal byte codes, UBCs, right? Which can be interpretable on any machine, that is JVM, Java Virtual Machine, right? Which is an interpreter, which is available as part of every operating system and as well available in browsers also, right? So this UBC consists of what? It consists of all bytes, right? So as I said, in C language, you have the tokens are the character set of C language. The character set of C language is what is coming from directly ASCII rather, right? And ASCII consists of how many? 128 characters. Okay. ASCII require how many bytes? 1 byte, right? We said. Out of which 7 bits are used to represent the character, and there is 1 bit for parity checking rather, right? Parity checking. That is in order to check the data whether it is error free or not, rather, right? So together are how many bits? 8 bits. So 1 byte, right? But whereas when you come to Java, okay, you have 2 bytes, right? Character consists of 2 bytes here, right? So 1 byte, of course, it is also making use of ASCII, but then it has been written it for universal kind. So you can write the Java program in all kind of languages. So the most significant byte, there are 2 bytes now. This is most significant byte, and this is least significant byte, right? So most significant byte is being basically generally used to represent if the program is written in other languages like French or German, Japan, or any other kind of language, Greek and all kind of thing. Or there are any other specification to represent that respective character. And the least significant bit is going to represent the character, which is again equivalent to same as that of your ASCII. Okay, fine. So this is how the characters are being represented in Java. Character requires 2 bytes, and all this data, entire data of your program, which is after being compiled, will generate the universal byte codes. Coming to floating point. You call floating point as real also in Fortran language or COBOL and other kind of languages. Okay. So basically, floating point exhibits an abstraction, right? Generally, in C language, we have 2 type of float, right? Float family consists of float and double, rather, right? Float and double in C language. Float consists of how many bytes? 4 bytes, and double consists of 8 bytes. Only difference is value ranges. The value ranges between -2 power 31 to +2 power 31 minus 1. Here is -2 power to 63 to +2 power 63 minus 1. Only thing is extension. You can have larger values with double data type. Right? Double data. So floating, basically, you can see here in this float data type, right? we have how many bits? 4 bytes means 4 into 8 is going to be 32 bits rather, right? 32 bits, right? So these 32 bits, how they are going to be represented? Fine. See, float consists of generally how do you write in mathematics? In mathematics, you write like 23.14. You say this you call it as integral part, and this you call the fractional part or the decimal part, right? But then in computer, this is going to be represented in two parts. What is that? Mantissa and exponent. Mantissa and exponent. So if I have to write this particular number in this form, then I say that form is said to be the normalized form. Right? So I need to normalize this in order to represent in this form, which is going to be understood by the computer, right? So how do I write? How do I convert this? I'll say that 0.2314 into 10 power 2. Both are equal, right? 0.2314 into 2 power 10 power 2. When you multiply this, fractional part, I say this is the mantissa. Right? After decimal, whatever the integer numbers I find, that is said to be the mantissa. And the exponent, right? 10 power 2. This 2 is the exponent, rather, right? So in computer, we represent the floating point numbers in this form, mantissa and exponent, right? So the question is, for mantissa, how much part is going to be represented? How much part is going to be given? And for what do you call exponent? How much part is going to be given? I mean, out of these 32 bits, how many are to be given for mantissa or fraction, right? Mantissa or fraction. And how much is going to be given for exponent, right? Is going to be decided by the manufacturer. It means the computer manufacturer, the hardware designer. Okay. So, like for example, if you have IEEE floating point number, in standard 754, this is these are some of the standards. One standard here it has mentioned. You can see IEEE is one of the IEEE standard for floating point representative, right? So, in which you can see 23 bits are being used to represent the fraction of the mantissa part, and 8 bits are being used to represent the exponent, right? 8 bits. This is 8 bits, and this is 23 bits. Out of 32 bits, 23 bits are being used to represent the mantissa, and 8 bits are being used to represent the exponent, right? Since all your floating point numbers have to be represented like this, the normalized one, okay, mantissa and exponent, on the fraction and exponent, right? So how many bits are being allocated for exponent? How many are being allocated for this by the language designer is going to be kept in secret. It means it will be hidden from the user. Okay, hiding the non-essential details is what said to be the abstraction, right? Abstraction. So this kind of abstraction is said to be floating point abstraction, right? This is said to be what? Floating point abstraction. This is said to be the data abstraction also, right? Which is going to be exhibited by all programming languages who are going to represent the floating point abstraction, right? Like C and the COBOL or Fortran, all such programming languages will allow you to represent the floating point numbers, including Java, every other latest languages, all languages will allow you. But then they will hide how they are going to be represented on the machine, right? And that is said to be the floating point abstraction, right? So these are some standards are given as part of IEEE 754, wherein if 32 bits are being allocated for floating point number, then out of the 23 bits are for fractional and 8 bits for exponent. And similarly, there is another kind of format is given. This is for for double. If you are representing a floating point number with the extended value, which is said to be the double data type, in which you find 64 bits, right? So out of the 64 bits, 52 bits are being used to represent a fraction, and 11 bits are being used to represent decimal. Decimal numbers generally, as you know, decimal digits consist of 0 to 9, right? 0, 1, 2, 3, and all kind of thing, generally being used to represent money or some number, some amount you want to show. You can probably use that. Okay. In COBOL, basically, which is being used for business application, where all the time you need to show the amount which you will be representing to the help of decimal triangle. Right? Decimal is a separate data type in COBOL. Generally, while representing the number, itself, you will represent where, for example, A is a decimal. So you can say decimal, or else you can just represent it like this: x. If I say x consists of alphanumeric. If I have to say, decimal number, I say variable A 999. 999 consists of basically 9 represents the decimal digit, of course, right? In COBOL language, right? In COBOL language. So this is how you represent variable A 999 means this A consists of 3 decimal digit. It means 3 digit value A can consist. If I want to represent, let us say, 5-digit value, then I have to select it. Okay. In COBOL, if I have to represent, let us say, floating point value, I say 0.99. Then what do you mean by it? A consists of 5 integer part. Integer part consists of 5 decimal digit, and this is the fractional part. Fractional consists of how many digits? 2 decimal digits, right? Precision with 2 rather, right? This is how you represent in COBOL, right? So advantages is accuracy, as I said, because the number when you are defining, you are clearly saying that particular number can consist of these many digits. I mean, it can have a minimum of 1 digit and maximum of 5 digits, of course, right? But then the fractional part also, you are giving an accuracy of saying that maximum of 2 precision you can probably use to represent, right? Disadvantage is limited range, right? And it wastes memory. If I have to, let us say, for example, declare a variable with let us say 5 digits, but then all the time I'll be using only 2 digits out of it, the remaining 3-digit value is going to be wasted. Or let us say I have represented A with 2 decimal digits, I can maximum up to go with 2 digits. If I have to represent a value for A with 3 digits, then I can't do that, right? So limited range and waste of memory is disadvantage of using this kind of notation in COBOL. Right? Boolean, as I said, is one of the data type introduced in C++ and Java and many of the other programming like Pascal and IROC and thing as well, which is being implemented with the help of Enumerated. Basically, Bool consists of 2 values, right? True or false, right? Basically, when you have Boolean statement, you can probably use this Bool data type, right? In C also, you can create a Bool data type of your own kind, right? You can say enum Bool, and then you can set the values for the same true and false, right? Then I can create an instance of the same Bool saying Boolean or B, then I can implement it, right? So I am allowed to create Boolean data even in C with the help of user-defined. Enumerated allow you to create the user-defined data. But then in some languages like C++ and Java, you have built-in Boolean data type, right? You can directly, straight away use that. Like in Java, we have Boolean. I can create a variable of Boolean like this. I can straight away use this B for true or false. Similarly, in C++ also we have both. In other programming languages also you have this, right? The advantages is readability. You can probably clearly show that whether it is true or false. So anybody can understand, instead of giving 0 and 1. 0 stands for false, I said, right? In programming language generally we use, and 1 stands for true. Instead of saying 0 and 1, if I say true and false, the readability is improved and one can understand easily. A novice person also can easily understand the same. That is the advantage of using the Boolean data type. Character. character without which, of course, you can't write a program. So all the characters set are the token of any programming language can represent the type of characters. So characters are really required for us. So as I said, all the programming languages make use of this ASCII. ASCII consists of 8-bit code, I said, right? Out of these 8 bits, 7 bits are being used to represent the character, and 1 bit, that is the most significant bit, the rightmost bit, right, is being used for parity checking. I hope all of you know what is parity checking. Generally, when you are sending the data from one particular device to another device, it goes across the channel, right? So in channel, you may have some kind of hindrances, some kind of disturbances, or some kind of noise, or some kind of attenuation, because of it the data may get changed, right? So in order to recover at the end, at the other end, we use this parity mechanism. So we have generally 2 types of parities. One is odd parity, another one is even parity. So in odd parity, what do you do? The number of ones that you're going to send, you have to ensure that they are odd. For example, if I have to send, let us say, capital A. Capital A is equivalent to what? 65. How do you represent in binary form? This is how you represent, right? This is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, right? Take this 0 and this 2 power 6, right? So 65, how do you represent 65 in binary equivalent? 1 followed by 6 zeros, and how many bits you are getting? 1, 2, 3, 4, 5, 6, 7. 7 bits you are getting, right? So these 7 bits are used to represent the character. Right? Is this equivalent to 65 or not? 2 power 0 plus is 1, right? So 1 plus, and these are all zeros. So even if you accumulate, it doesn't give you any value. 2 power 6 is how much? 2 power 6 is how much? 64. Yes or no? 64. So it's going to be 65. So this is the equivalent of A. Let us say this is the sender and this is the receiver. Sender could be some kind of input device here, and receiver, let us say, some CPU and all that, right? So when I have to send some A, that A is being sent like this, right? But then these 7 bits are being used to represent the character A, but ASCII consists of 8 bits. So what will be the most significant bit? There is another bit that you have, most significant bit. So this is going to be judged based on the kind of checking you are using. Let us say, for example, if I'm using odd parity, right? If I'm using odd parity, number of ones to be sent should be in odd. So the 7 bits, if you see, out of the 7 bits, number of ones are even. So what should I take in order to make the number of ones to be odd? That should be 1 here, right? So most significant bit value will be 1 here. So A, when I am sending, if I am using odd parity checking from sender to receiver, the data of the binary data equivalent of A will be sent from from input device to the CPU is nothing but this one, right? 1 1 0 0 0 0 0 and 1. Okay, if I am using even parity, then what happens? This has to be 0. This has to be 0, right? So that's how the parity checking mechanism is being basically used in order to ensure that the data being sent reliably across the communication channel, so that at the other end, when it receives the data, it can check for the data validity, and it can ensure the data is correct. If not, it can probably ask the sender to retransmit the same and recover it by getting it from the sender, right? So this is how generally the data communication is going to happen across the different devices that you have of your computer, right? ASCII is the one which is being used by ASCII coding system is being used by most of the programming languages, almost all the programming languages that can be used. I mean, the most significant byte, right? There are 2 bytes now here. 16 bits means 8 bits here, 8 bits here. So this is your MSB, this is your LSB, right? So this is being used to represent the languages, and this is being used to represent the ASCII, right? Ultimately, of course, Java also uses the ASCII. Even Unicode uses up the ASCII in most of the cases, but then it helps you to make the programming language more universal, right? Yeah, coming to string data type, the set of characters is said to be the string. So generally, okay, in order to represent the name, okay, or any let us say account name, account number, where you have multiple characters, for the same represent, including special symbols. For example, somebody's name, Nitish Rao. So how do you write Nitish Rao? And let us say in the name, I want the rule number to be attached to it, rather, right? So with some delimiter, I can use a delimiter called, let us say, underscore, and then I write his number, rule number, let us say 2451. 2451 batch is 20, and let us say 733, and his number is, let us say, 149, something like this. Okay, so this whole to be represented, where you can see I have characters, I have special symbols like this underscore, hyphen, all, and you have digits also. So in that case, I need to go for strings, rather, right? The string consists of all set of a set of characters. So character includes everything, rather, right? Character includes all, include digits, it includes special symbols, it includes alphabets. Okay, and while designing the data types, if say for example in C you don't have string as a data type, but whereas in Java you have string as a data type. So then you must have to define the constraints for using the same, right? What should be the length of that string, whether it is a static or dynamic, and whether it is a primitive kind, and all kind of thing, right? So basically in C it is not a primitive data type, right? It is being used as an array data, right? Is being used as a these are all going to be basically defined by the programming language designer at the time of specifying the data types, while including these all different kind of type of data to be rather represented in the programming language. Okay, so next coming to the string types. When you are basically using string as a data type, like for example in Java you have a string as a data type, then you need to specify the operations, right? What kind of operations you can rather allow to perform on that particular string data type, right? Basically assignment you will allow, and copy allow, you will allow, comparison you can allow, concatenation you can allow, substring, finding the substring of the same, or finding the pattern matching of the string, substring you can probably. So the language designers, when probably they are defining a particular data type like string as a primitive data type, because the string is a primitive data type in Java. So then you need to specify the operations, right? These are all kind of operations. Of course, in C language, you don't have string as a primitive, but then you can have it as a character array. Okay, it is a character array which you have already studied, right? And in C++, it is not primitive, right? You use character array to represent the set. In order to perform those operations, you will be using library functions in C. You have string.h, right? String.h you may have included while performing the string operations. Okay, you are allowed to have different kind of operations here, like string concatenation, strcat. You have str, cmp. You have to compare two strings, and str.len to find the length of the string, and all kind of things. Right? So in C++, they are not primitive, but then you can implement it with the help of a character array, and you are allowed to have some sort of library functions which are being given by the programming language itself. This library function can be defined by the user itself. User also can define. You may have written user-defined functions for these all, my string cat, my string compare, my string len, and all kind of thing. You may have written as part of your library to be written for the string handling functions, right? So these are, I mean, basically library functions without which you can't implement many of the stuff of the program, but at the same time, they are not the part of the programming language. You can define your own libraries also, right? That provides you set of operations which probably make your programming more easier. If you go to Snowball basically a string manipulator language, we call it as. So that's the reason why you can find string is a primitive data set, and many of the operations that you can probably perform on the string, as we discussed, are available as part of the language, not as the library data, right? As a part of the language itself. In Java also, as I said, they are primitive via string classes. String classes is a package which you have to basically in Java. Even everything to perform, you have packages. So you need to import these packages in order to implement the classes and respective methods that are available in the particular respective package for the same value, right? Yeah. So now static COBOL. Coming to string length operations, you have to find the length of the string. We have COBOL, Java, a string is a static class. In C and C++, this varies, right? Limited dynamic length. You can probably have your own, length of string by specifying the size of the array. Well defined. Snowball, 4 and Perl, JavaScript as well. These are dynamic. You can have any length of string rather, right? ADA supports all 3 string length options. You can have static length strings, you can have limited dynamic length, and you can have dynamic with no limit rather, right? String type evaluation. It gives aid to writability. Basically, when you have strings, you can straight away start performing the operations of that specified as part of for the programming language directly. Right. Primitive type strings are specified with static length. They are expensive to provide. You can do that. Specifying inside that itself. Monday can start with 1 and Tuesday can start with 2. It depends on the language design. So these are the specifications of the programming language, right, which are going to be defined by the language designer. Whether he is going to fix these attribute values to start with always 0 itself, or is he giving you to flexibly assign the values for the same? Because through language design, like for example in C language, it will allow you to use both the things, right, to represent the value of this particular instance of this particular data type, right? Monday could be either 0, or you can directly use 1 also, MON, or you can use 0. Or if you are specified with some other kind of value for like 1, so you can represent it with 1 or MON for the instance of this particular data, right? So these are going to be specified at the time of the design itself. So these are what the design issues which has been associated with this particular data type, which have been discussed here. You can see in the subsequent lines. Is an enumeration constant allowed to appear in the more than one type definition? And if so, how is the type of an occurrence of the constant checked, right? How is it going to be checked? Is it going to be checked with the help of value of the particular attribute name you have to? Are enumeration values coarse to integers? As I said, right? They can be varied or can be fixed with any other type coarse to an enumerated data type. So all these are going to be a part of the language issues, which are going to be set by the language designer at the time of designing the language. It provides help to read towards aid to the readability. Fine. No need to code a color as a number. For example, generally colors are represented with some kind of number, right? So that numbers can be given some names here with the help of this enumerated data type. And in programming, instead of that number will be so big, right? So I can use that color name. Let us say, for example, blue. Blue consists of some number. You don't understand that number. It's a big number. Sometimes it's in hexadecimal type, right? So if I have to, let us say I have created a enumerated color data type enumerated color. I said blue equal to that respective value. And then I can have comma. I can have green like that and out. Okay. So while I have created an instance of this color, let us say C. So the color, or say window color, I can say instead of C, I say window W. So W color. W color, let us say blue. So I can just say W equal to blue. It means window color is blue. Otherwise, I need to write that entire value. That value is so big, where readable it is not readable. Rather, a English person cannot understand what is it rather equal to it. Rather. If I say W equal to blue, where blue was already specified with a particular value, which is associated with a particular specific color. So in programming, it helps me to improve the readability. Any English person can easily able to understand my statement, right? It provides aid to the readability. Compiler also can check easily by converting it into the respective integer equivalent and of anything. So fine. In Ada, C hash and Java 5.0, it provides better support for enumeration than C++ because enumeration type variables in these languages are not coerced into integer type. Okay, on my leisure time. Okay, thank you for now.